Guys, so today we're starting 6-1. In 6-1, you're going to be able to extend our property of exponents to rational exponents. And we're going to solve some equations with rational exponents using the properties of exponents we spent some time on. So let's review our rules of exponents. All right, we spent some time doing this, but let's just write it all out. So when we multiply, we add exponents. Okay, so x squared times x to the 5th is equal to x to the 7th. Power to power, we multiply. So x cubed to the 4th power is just x to the 12th. When we divide, we subtract the exponents. So x to the 10th over x to the 7th is equal to x cubed. Anything to the 0 power is 1. Okay, negative exponents are reciprocals. Move them across the fraction bar and make them positive. Okay, so x to the negative 4th is the same thing as 1 over x to the 4th. 1 over x to the negative 2, we'll move it across the fraction bar, it becomes positive. Okay, and then when we have a product or a quotient inside parentheses and the exponent outside, we're going to distribute the power to everything, including the coefficients. Okay, so here we take the 4 to everything. So we get 2 to the 4th, x to the 24th, y to the 4th, z to the 12th. Okay, or 2 to the 4th, 2, 4, 8, 16, x to the 24th, y to the 4th, z to the 12th. Okay, same thing with the quotient, I take it to everything. So 3 squared, x squared, y to the 4th, over z to the 16th, and then 3 squared, again, remember, is 9, so x squared, y to the 4th, over z to the 16th. Okay, so we should be comfortable with these rules by now. Okay, so here comes the harder stuff. What happens when I have a fraction as the exponent? Okay, think of 3 to the 1/2. Well, we know exponents mean repeated multiplication, where 3 squared is equal to 3 times 3, 3 cubed, 3 times 3 times 3, 3 to the 4th, 3 times 3 times 3 times 3, so on. Okay, but what does 3 to the 1/2 mean? We cannot multiply 3 by itself 1/2 times. So since interpreting exponents as repeated multiplication does not work in this case, we have to come up with a new meaning. So whatever the definition is, it needs to obey the same rules of exponents that we know for integers, okay, such as power to a power. Well, I know if I take 1/2 times 2, I get 1. So 3 to the 1/2 squared has to equal 3. Okay, so the number whose square is 3, if we go backwards, would be the square root. So in order to define raising a number to the 1/2 power in a way that makes sense, anything to the 1/2 power is the square root of that thing. Okay, so we have we can generalize this to any kind of rational exponent. Okay, so the nth root of a is a real number, and m is an integer, and a to the 1 over n is equal to the nth root of a, and a to the m over n is equal to the nth root of a to the m, or the nth root of a to the m power. Okay, let's generalize it. Your numerator becomes the exponent on the inside. Okay, so say the 1 goes here, the m also goes inside. The denominator becomes the index, or what root you're taking. Okay, it's the number outside the radical. Okay, so the n in both cases becomes the nth root. So you could do the cubed root, the 4th root, the 5th root, whatever you need to do. Okay, so make sure you know this. Okay, so what does 2 to the 1/3 equal? Well, I know it's a root, but the 2 inside, the top stays inside, the bottom becomes the root I'm taking. So this is just the cubed root of 2. Right. So why do we need that? Well, we've got some equations in order to be able to solve. Okay, so 3 to the x over 2 times 3 to the x over 3 is equal to 3 to the 9th. Well, in problems like this, notice my bases are the same. Okay, so we've done these problems. Okay, so when I multiply, what do I do to my exponents? Well, I add my exponents. So this just becomes 3 to the x over 2 plus x over 3. And that has to equal 3 to the 9th. Well, I don't like x over 2 plus x over 3. I want to make that one simple number. So here's a question for you. How do you add fractions? Well, we need a common denominator. So what's my common denominator between 2 and 3? Well, that common denominator is 6. So how do I get from 2 to 6? I multiply by 3. If you do it to the bottom, you have to do it to the top. So that becomes 3x over 6. Same thing over here. How do I get from 3 to 6? Multiply by 2. If I do it to the bottom, I have to do it to the top. So it becomes 2x. So really, this is just 5x over 6. So 3 to the 5x over 6 has to equal 3 to the 9th. Well, oh, my bases are the same. So in order for these to be equal, my exponents have to be equal. So I can set 5x over 6 equal to 9 and solve for x. Okay, so to solve for x, we're going to multiply both sides by 6. 5x equals 54. Finally, just a one-step equation, divide both sides by 5. X is equal to 54 over 5. Okay, so let's just think that through again. Okay, some easier examples here. 3 to the x equals 3 squared. Well, these have to be the same, so the exponents have to be the same. So x has to equal 2. Okay, 2 to the 8th equals 2 to the x. Well, in order for these to be the same, the exponents have to equal each other. So x has to equal 8. Okay, it doesn't matter what your base is, the exponents have to be equal. So in this case, x is equal to 6. Okay, so when the bases are the same, we are allowed to set the exponents equal to each other. This helps us solve equations. Okay, so let's do another one. 2 to the x over 4 times 2 to the x over 6 equals 2 cubed. Okay, well, again, I know I'm multiplying, so I'm going to add those exponents. Okay, so you got to think to yourself, okay, how do I add subtract fractions? Well, I got to have that common denominator. So my common denominator between 4 and 6 is 12. So 4 times 3 gives me 12. So if I do it to the bottom, do it to the top. 6 times 2 gets me 12. So if I do it to the bottom, do it to the top. This gives me 5x over 12. Okay, so I have 2 to the 5x over 12 equals 2 cubed. Okay, well, the exponents have to be the same in this problem. So I can take 5x over 12 and set it equal to 3. How am I going to solve for x? Well, multiply both sides by 12. 5x equals 36. Divide by 5. X equals 36 over 5. Okay, let's make it a little bit more challenging. Okay, this time, my bases are not the same. Okay, so I am allowed to rewrite that big number. Okay, always look at the bigger number first. Okay, so 27 versus 3. 27 is the bigger base. Can I rewrite 27 as 3 to a power? Well, I know 3 to the first is 3. 3 squared is 9. 3 cubed is 27. No, so I can replace this 27 with 3 cubed. Okay, that's the same thing as 27, so I'm allowed to replace it. Okay, sometimes some problems you're going to have to rewrite both of the numbers, but this one we only had to rewrite one. Okay, well, look at this. I have a power to a power. What happens when I have a power to a power? Well, we just multiply. So this is 3 times 3 to the 3 times x minus 4. Okay, oh, my bases are the same. Therefore, the exponents have to be the same. So I know that 3 times x minus 4 has to equal to x minus 6. And we're good at solving this stuff. So let's go ahead and solve. Distribute here. 3x minus 12 equals 2x minus 6. I'm going to subtract 2x from both sides. X minus 12 equals negative 6. Okay, let's add 12 to both sides to get x by itself. Therefore, x equals 6. Okay, this one, we're going to have to rewrite both. Okay, we have 1 over 25 and 1 over 25. Well, I see 25, I immediately think 5 squared. Okay, So, but I don't like fractions. So how can I get 5 squared to the top? Well, that's the same thing as a negative exponent. So this side really becomes 5 to the negative 2. And then I keep that other exponent. Okay, well, 5 to the first is 5. 5 squared is 25. Okay, oh, 5 cubed, that's 125. So this is really 1 over 5 cubed. Again, I don't like fractions, so how am I going to move that to the top? Again, I'm still using negative exponents. So that's going to become 5 to the negative 3. Okay, so now, oh, wait a minute, things are the same. I see a power to a power on both sides. So I know this is going to be 5 to the negative 3 times negative x over 2 equals 5 to the negative 2 times negative x over 3 minus 2. Oh, bases are the same. Let's work with just the exponents. So negative 3 times negative x over 2 is equal to negative 2 times negative x over 3 minus 2. How am I going to solve both of these? Well, we got an exponent, or multiplication, so just multiply. Negative 3 times negative x over 2 becomes a positive 3x over 2. Okay, here I'm going to distribute. This becomes positive 2x over 3. Negative 2 times negative 2 is a positive 4. Okay, so we now need to get all of our x's on the same side. So I'm going to subtract 2x over 3. Okay, so you can put this into your calculator as 3 over 2 minus 2 over 3. Okay, if you wanted to do it by hand, remember common denominator. So my common denominator would be 6. Multiply this one by 3. So it becomes 9. This one I'd multiply by 2, becomes 4. 9 minus 4 is equal to 5 over 6. Okay, and they have the x's with it. So this is 5x over 6 is equal to 4. How do I get x by itself? Well, I'm just going to multiply by the reciprocal. So x is going to equal 24 over 5. Okay, complicated problem there, but take it step by step. All right, here's a few for you to try. Pause the video, try letter A, and then we'll go through it. Okay, so I see 256, I see 4, so let's look at 4 to the power. 4 to the first is 4, 4 squared is 16, 4 cubed is 64, 4 to the fourth is equal to 256. Oh, so I can take this and replace it as 4 to the fourth. Okay, oh, power to power. I'm going to multiply. Okay, so my bases are the same, so I can set my exponents equal. And let's solve. I can distribute. Okay, get all my x's on the same side. And then get all my numbers on the same side. So x equals 1 in this problem. Okay, pause the video and try part B, please. Okay. Well, I'm seeing 4 and I'm seeing 8. I know 4 is 2 squared, so this is 1 over 2 squared. Well, 2 cubed is the same thing as 8, so 1 over 2 cubed. Okay, but I don't like fractions, so let's bring it up to the exponent. So this becomes 2 to the negative 3 to the x over 2 minus 1 equals 2 to the negative 2 to the x over 3 power. Okay, power to power, I'm going to multiply. So 2 to the negative 3 times x over 2 minus 1 equals 2 to the negative 2 times x over 3. Okay, my bases are the same, so now I can set the exponents equal. Okay, so let's go ahead and solve. Distribute here. So negative 3x over 2. Negative 3 times negative 1 is a positive 3 equals negative 2x over 3. Okay, remember, multiplying fractions, you just put it over 1 and multiply straight across. Okay, so I'm going to get all my x's on the same side. So I'm going to get rid of this one. I'm going to add 3 over 2x. Okay, so in your calculator, negative 2/3 plus 3 over 2. You're going to get, again, 5/6. And now I'm just going to multiply by the reciprocal. X is equal to 18 over 5. And there's your answer. Okay, so we're going to do a word problem, or 2 word problems. These word problems are pretty tricky, so make sure you're paying attention. Okay, on tests, I probably won't give you these word problems because they are very complicated in my opinion. But let's walk through one to see what it looks like. Right, so Adam's setting up for an outdoor concert. He places 3 square blankets near the band as shown in the picture. What is the area of blanket C? Well, how do I find the area of a square? Well, area is just equal to side squared. So to find the side, we would just square root both sides. So side would equal to the square root of a. But when we're working with exponents, that would be the area to the 1/2 power. Okay, something we talked about at the beginning of the lesson. So I'm looking for blanket C. Well, I don't know anything about blanket C, but I know this rectangle right here has an area of 12 yards. So I can find what x is, because I know this side is x, by using what I know. This area is 8, so this side, if I use this right here, would be 8 to the 1/2. Okay, this area is x, so the side would be x to the 1/2. Therefore, area equals length times width. 12 would equal 8 to the 1/2 times x to the 1/2. Okay, that's where that comes from. So let's go ahead and simplify this. Okay, so this is kind of a new rule. Anything to the 1/2 times something else to the 1/2, I could just kind of undistribute that exponent. So this is really just 8x in parentheses to the 1/2 power. Okay, think about that rule backwards. If I have product, I distribute it to both pieces. So I can pull that product back out. Okay? So then, how would I get this by itself? Well, this is just the square root. How do you undo the square root? You square both sides. Okay, so if I square it, this gives me 12 squared equals 8x. Got to square, this would give you just 1. Well, 12 squared is just 144. So to get x by itself, divide both sides by 8. X is equal to, throw that in the calculator real quick, 18. Okay, well, x was the area of blanket C, so blanket C has an area of 18 yards squared. And that's that problem. Okay, I'm going to skip this one for now, because this video is going long enough. Okay, last problem we're going to look at. Terrarium A and terrarium B are cubes. The side length of terrarium A is twice the side length of terrarium B. What is the value of x? Okay, well, volume for a cube is equal to side cubed. Okay, so this volume 2x is equal to side cubed. Okay, over here, 2 is equal to side cubed. Okay, so I know that this side, or this side right here, is twice the side over here. Okay, so I know if I take the big one divided by the small one, I better get 2. Okay, so my big side, okay, if I cube both sides, which is the same thing as multiplying it or raising it to the 1/3 power, I get 2x to the 1/3. And this one, same thing, I can raise it to the 1/3 power is how I get to the 1/3. That has to equal 2. Okay, So let's start thinking about our rules of exponents. Here, this is just division. What do I do when I have division? Well, I subtract those exponents. Okay, so if I simplify the top there, power to power, I get 2 to the x over 3, divided by 2 to the 1/3. I can now subtract my exponents. Okay, so 2 to the x over 3 minus 1/3. Oh, those are common denominators, so I can make it one big fraction. So 2 to the x minus 1 all over 3 is equal to 2. Now what exponent does 2 have? Well, 2 just has a first. Oh, look at this. This looks just like some of the other problems we did. Okay, so I can take these two and set them equal since my bases are equal. So x minus 1 all over 3 is equal to 1. What would I do first to get x by itself? Well, I'd multiply both sides by 3. So x minus 1 is equal to 3. Simply just add x equals 4. Okay, so not as bad as, look, setting it up there, though, is the tough part. Okay, and we're going to just skip that one for now. Okay, so here's a summary. You can find that at the end of your book, okay, but it just goes through the exponent rules that we've spent some time on. So homework tonight, I would like you on page 222. Please try problems 21, 24, 25 through 41 odd. Okay, and don't worry, we are going to practice this for a couple days. Okay, please come with questions. See you guys later.